last time we concluded the lecture by very briefly looking at the use of questionnaires, and I would like to expand a little bit on that, because very often people use questionnaires without thinking too much about the efficiency or efficacy of using such questionnaires. The reason why people seem to use a lot of questionnaires is it is something very easy to develop and easy to mail, and they expect the respondents to respond reasonably accurately and fast to their questions, and also the method is somewhat less expensive, because one does not have to go personally to individuals. You can just mail it and expect that the questionnaires will be returned. But in actual practice, this is not really true. Very often, if the questionnaires are very long, the response in terms of, suppose you mail out 100 questionnaires, even getting back something like 10 or 15 becomes the norm. In other words, most people consider questionnaire as something very impersonal, and that it may not be used effectively, and they do not really spend a lot of time doing it, and it becomes one of the things to be done and goes under the pile, and finally if some reminder comes, they will come back, take it back again and see whether they can fill it up and so on. And also I have observed that, for instance, when I give my vehicle for servicing, they give a questionnaire about the type of servicing and so on, and the questions are such that the responses are excellent, good, fair and poor, and most people have a tendency not to mark it excellent or not to mark it very poor, but just mark it good or fair, and this does not really convey much information about what that company sought to get in terms of the efficacy or efficiency of whatever servicing they do. So, to some extent I think this is as I said, wasted effort, but questionnaires are very useful for gathering statistical data when the number of persons is very large. But here also there are a lot of difficulties. I remember one big survey which was done for urban reconstruction in a big city in India. What they did, the collectors of information, that is they made a questionnaire, and they did not really try to look at the beginning what questions are to be asked in order to be able to get the kind of conclusions they want to draw from the study. So, they collected a lot of information, including information on income, the type of houses they live, the locality where they live, and things of that type. And the one thing they forgot is that when they say income, they very often the person who went out to do the survey looked at the family income, where in the poorer families more than one person works, or 3 or 4 people work and they all live together, and so the income is quite inflated, and the conclusion seemed to be that people with fairly high income are really living in slums. So, this kind of a conclusion obviously was not correct, because the way in which they collected the data, they should have really asked how many people are there in the family, how many people are earning members, and then try to conclude based on the on that in terms of what is the relationship between the individual income, which is what they are looking for, and the type of residence you would like to or she would like to be live in, on the area in which one would like to live in. So, this kind of a problem occurs too late, because what they had done is to send the questionnaire with people who are collecting it house to house, and a fair amount of that is done. It took about a year to do the work, and then when they finally found out that not one of the most important things they wanted to get out of this was not available, because they just didn't ask the right question, they get into deep difficulty. So, even in questionnaire design, it is extremely important to very carefully look at what are the ultimate objectives of the study and work backwards from the objectives towards the questions you ought to ask, so that the objectives the answers can be used to meet your objectives. So, this is one thing which is careless design of questionnaires is very common. So, as I said, you have to enumerate all the objectives and go backwards to find out the data which are needed to meet this objective. And if the questionnaire is very long, very few people will actually answer it. So, the questionnaires have got to be simple, precise, short and to the point. Then the success of getting your replies are more, and of course, many companies also give some kind of an incentive, saying that if you return the questionnaire, there will be a lucky draw and you may get some prizes and so on. And of course, that does not always entice too many people to do the questionnaire filling, because after all it is a lottery and you do not know whether you are going to get it or not. So, you would rather spend that time in something else. So, that is essentially what really happens even in terms of incentives. So, even if you send out a questionnaire by post, it is important to follow it up with personal interviews, and if you make a phone call and ask for responses, people are very reluctant. Now, they feel disturbed with phone calls which come from odd people at all odd hours. And in fact, now there is a law coming up in many countries including India, that unsolicited phone calls to people at odd times cannot be done, because of the fact that it unnecessarily disturbs the privacy of the individual. So, it is better to kind of interview them personally after actually setting up some kind of a time with the person, so that he knows and is also prepared for the person who is going to collect the data that he is coming. And this course is possible only if the target is small and if it is it serves a specific purpose. In the area of systems analysis, it does serve a purpose. Like we want to do a marketing survey in terms of trying to find out, we are coming up with a new hardware product, maybe like a new type of laptop. You would like to know who are the people who would most likely buy it, and so you have to really get to know this, and this is the kind of marketing surveys they try to do by looking at the different types of what they call markets, of different people who are the potential buyers of this product, and then try to ask the right questions and target them, saying that suppose the price is between 20,000 rupees and 30,000 rupees, will you buy it, or is it, if it is below 20,000, will you buy it, at what level of cost do you think it is worthwhile buying, and things of that type. So, a lot of both qualitative and quantitative questions are asked in such marketing interviews, and obviously you cannot really do a very extensive survey. You have to do a so called sample survey, come up with a sample of different market segments and go and do this survey in these market segments. So, in marketing also these systems are very often used, because ultimately the results of all this surveys and so on are analyzed by a computer to come up with some conclusions which can be used by the management to take appropriate decisions. So, that is the whole idea of doing it. And there are so many cases where people do not really understand that just merely collecting the data using questionnaires is not enough, because once you collect this data, you have to analyze it, and you got to get some positive conclusions. And so the analysis and programming and coming to proper conclusions, all that requires a fair amount of effort and time on the people, on the systems analysts and others, consulting people who are very knowledgeable, to make this kind of a survey effective. And so there is a lot of expense after the collection of the data, and very many places they just don't understand that analysis of massive amounts of data costs money, both in terms of people's money and computer time and things like that. I remember one survey where in fact it's a lot of work they did. They are actually breeding sheep somewhere in Rajasthan, and trying to find out the kind of breeding methods, kind of fodder they should give, and the hardiness of the animal to kind of various diseases. And they had done extensive kind of work with many types of sheep and crossbreeding and different types of fodder to find out the wool yield and how the wool yield increases and so on. And so they had collected a huge amount of data over something like 2 years, and they had all that data in a reasonably interesting form, but then as usual many of them are written up manually in a register and so on. And then they came to our computing facility and said that we got all this data, now I want to analyze that and try to get some conclusions about what type of fodder, what kind of breeding, what kind of breeding will reduce things like certain diseases coming, and which will increase their yield and things like that. And so I asked them, all right, I mean, first of all we got to convert all this handwritten data into a codified form for analysis by computer, and then you have to write the right program, and you have to really analyze what exactly you require and write a program accordingly, and then come up with proper reports, graphs and whatnot, so that the management or the people who are going to do this work will actually use this. So then I asked, how much budget have you allocated for this purpose, because it is going to cost you a reasonable amount of money. And he said, well sir, I didn't really know that it costs a lot of money to analyze and so on using computers, and I did more, we had very little money left in the project. And I asked him, what is the total money you spent on the entire project? So sir, we spent about 4 crores of rupees for 3 years. And I said, what happened to all that money? He said, sir, the goats ate it up. Okay, this is the kind of response they said, because goat had to be fed, and most of the money went for that. But ultimately, the end of the study, they just didn't analyze it, so the whole thing went waste. What they had to go back and try to get some funding for the analysis, so that the entire study will now become really useful. So this again shows the fact that many people in general public, particularly people who are working on these kinds of areas, do not understand the time required and the cost required to analyze data and to come up with appropriate conclusions. So it is very important for the analyst to be involved also at the time of any large experimentation which people do, things like breeding experiments and so on, so that also the right kind of analysis can be done at the appropriate time, so that there is the money is not money is allocated appropriately for each segment of the work to be done, so that the budgeting is done properly. So these are all may look trivial, but these are things which you have to remember in actual practice. In practice, people don't really seem to have a lot of common sense. They kind of think that computer and computer use is going to be almost free of cost. The maybe actual computer and the programming and all that. The computer cost is low, but the programming cost and the people cost and analysis cost is very high. I mean, these are issues which has got to be understood by the managers and management of any organization, and that is the responsibility of the systems analyst to make that known to the people who are to be involved. Apart from the methods I have been talking about for information gathering, the other very common areas which you look at are existing systems, if any. What I mean by existing systems is that that particular company would like to say put a new system, and they may have an existing system, or you kind of look at a similar organization which is doing similar work. Suppose you are doing an analysis and design for a courier agency, and you may look at what some other competing courier agency does, and that may be either available in public knowledge or it may be available in some even many of them give a case study at the end of a particular job. They may not give all details, but at least give an overview of what they did to kind of computerize their courier operations, the chain of tracking of items as they go along and so on. Okay, so you look at existing systems, you look at systems of similar organizations, and go also to look at the workflow. In other words, what really happens in the organization. In a courier organization, for instance, how does the data and items flow? Just looking at it, see, normally what happens is that either the agency collects the item from the customer if it is a large customer, or the customer goes to the agency and delivers it. Immediately a receipt is given that this item has been handed over, and time stamp is also set. At this time it was given, this much is the weight, and also the charges. So these are all done at the very beginning, and then once that is done, then there is a certain guaranteed time by which that package is supposed to reach. So the question is, what kind of guarantee do they give? If they give different, they could have different categories. It could be an overnight, next day it should go, or it could be more relaxed, like they are willing to wait for 48 hours, in which case the cost may be lower. So there will be a tariff depending upon the urgency, and there also will be a tariff depending upon the cost of the item. If the item is very expensive, they have to take an insurance on that item, so that in case it is lost, they will reimburse the customer. They also have to ask the customer what that packet contains. So these are all the issues which are important, and then once it gets in, then the actual process starts of putting it the appropriate transport method, either air or truck or train or whatever, and then at the receiving end do the similar thing of being able to receive it, track it, and then look at the address of the recipient, give it to the recipient, take the signature, and then the entire cycle is complete. And very often you may also send an acknowledgement back to the person who dispatched it to say that it has reached. And nowadays many companies also try to keep the entire movement of that item on the computer, so that the person who is sent the item can actually track it, or even the person who is receiving the item, given that the number, which is unique identification number assigned to the item, they can look at that unique identification number and say what is the actual place where is it in, and how long will it normally take for them to get it, and if it is it stuck somewhere, and so on. So there are many things which now are amenable to computerization for such companies. In fact, this is called logistics and so on. Logistics is one of the large areas, developing areas, which is where computers, particularly internet based interconnected computers become extremely useful. So, the last thing is the so called case repository. What I mean by case repository of in an organization is that a large organization which does a lot of systems design and analysis normally will have a library of previous similar things they did. A good organization, that means it's an organization which is reasonably well organized and has got a fairly large number of people working on it. What I mean by this is companies which are which got 7,000-8,000 employees, like larger companies in India like Wipro or Infosys or TCS and so on. They do so many projects over the years that they normally try to keep a library properly classified of the various types of systems they have analyzed and for which they have developed and delivered systems, and there is also a lot of information about sometimes the problems they encountered, and the general analysis which they did. Okay. So, this case repository is very useful. So, if you are starting on a new project and you have not done it similar thing before, these companies provide you on your desktop machine a method of searching the library, and it is normally some kind of a digital library to find out if there are similar cases or similar situations which have been actually tackled already by the company. So, if you are able to identify that, then you can get a lot of information from that in terms of what type of questions to ask and what type of responses to expect and what type of ultimate system would normally be good for the customer or will satisfy the customer. Okay. These are issues which are one has to keep in mind that it is important for any large organization to create what I would call a knowledge repository, knowledge base based on previous experience. And this knowledge base based on experience is something which is extremely useful for new people starting out, because then you kind of stand on the shoulders of others who have already gone through all that earlier problems and so on, and removed all those, encountered all kinds of little difficulties and how they tackle the difficulty and how they kind of solved it. So, this is always useful. So, a good organization will always keep a good repository of knowledge and also good classification. So, that classification is very important to be able to retrieve the required information fairly easily. So, there is a large, you might say, library of cases and a repository, you might call it a repository in their own consulting organization. Now, having the whole idea of gathering information is to come up with a systems requirement specification. I have been saying again and again that systems requirement specification is a very, very important document which is agreed to between the users, the ultimate people who want to use the system you design, and the designers who are going to design the system. And it's but the term specification really says that it only tells what information is required to be provided, and does not say anything about how it is to be done. You have to be very clear about this, because very often what and how are confused. How gets into details of doing it. What you require is only gives an overview of what you are what are the required desirable things you require in the system. So, the specification in the case of human systems, like what we have been essentially talking about for things like logistics or financial systems or whatever, all the systems which or for which computer based systems are actually designed, are, as I said, human systems where humans become part and parcel of the entire chain of passing information and using documents and things like that. And so, the methodology for specifying information or the specification method, which is the same what is to be done, is not amenable to some kind of what one would call a formal specification. There is an area called formal specification people have been looking at for many years. By means of what is meant by formal specification is something which is more mathematical in terms of saying the hypothesis and then the conclusions or this kind of a pure mathematical specification. Let me take an example of what I really mean by mathematical specification. You know, if you are going to design a suspension for a motor car, the motor car suspension is normally modeled first as consisting of the weight of the car plus the spring and the shock absorber and the tire, which has also got certain springiness and shock absorption capability. And this is actually put, the specification now is in terms of this model and then equivalently described by means of differential equations. It may be a non-ordinary second order differential equation, or it could be a second order differential equation, but coupled. One part dealing with the dashboard and spring, the other part dealing with the tire and the amount of air in the tire and stuff like that. So, there could be two aspects, it could be a coupled system, but this is specification, and it only says what does this what kind of formally describes the system, and then you solve that to try to find out how well this will work and things like that. Is how to pick the right dashboard, spring and so on to get your ultimate objective of a smooth ride when you go through a bump or when you go through potholed roads like in Bangalore. Okay, and so you really, this whole idea is to try to come up with a design which is the ultimate objective. Similarly, people have been trying to see if there are any formal methods like differential equations and so on, but they have not been able to come up with anything. There is something called a Vienna definition language, which IBM tried to kind of propose, but it was not acceptable because many managers and others are averse to even looking at mathematics. Mathematics kind of puts them off, and so you cannot really use anything which is too mathematical to explain anything to lay managers. That is, they are really people who are not really, all that comfortable with mathematics, unlike engineers are. Okay. But there are certain systems where formal specifications are absolutely essential. Like for instance, when they designed the signaling system, automatic signaling system for the fast trains in France, and also some of the metro rail systems and so on, which are all coming up in India now, where the signaling is all automatic. What I mean by automatic signaling is that it is not like the old manual person changing a point and so on. The whole thing is controlled by a computer, and the computer has access to sensors whenever a train moves and where the train is and so on, and based on that it does the proper signaling, so that reasonably fast transport take place, and can also be a safe transportation. In this case, unless you formally specify it and clearly understand the requirements, you could lead into very major accidents. So, in such cases there are formal specification methods have been used very successfully, and they have been found essential. The kind of specification they use are something like state diagrams, the Boolean algebraic methods, logic systems, and so on, which they have been they have used very effectively in such systems. And so the point I am trying to make is there are variety of subsystems, and I am not going to really be talking about the systems which are safety critical, like a rail system or even an aircraft landing system, which is all now controlled by a computer. So, those things are safety critical, where you require formal specification, and you got to have a clarity in terms of the ultimate requirements, and what is required has got to be very clearly mentioned, that too formally. Okay. So, the point is that the in the kind of systems we are going to talk about, which are mostly human systems, we will not be really talking about formal specifications. In some other course we are going to take on real time systems design and so on, then you will definitely learn about the formal methods, because they become very important for such systems. The systems requirement specification, in the case of companies for which you actually are writing systems, is based on extensive discussions. As I said, interviewing techniques is one of the most important methods of getting this information, so that the systems requirement specification can be drawn up. And the drawing up of the SRS is the most important and the most difficult task of a systems analyst, because if the SRS is not drawn up properly, then the system you design will not satisfy the user ultimately. So, there is always this misunderstanding between what the user really wanted and was not able to say very precisely, and what you understood. In fact, there are a lot of jokes about it with cartoons and so on. One simple joke might say that a user said that he wanted to have a transport vehicle where two people can travel comfortably, and it should be least energy, it will be energy efficient, it should not use up too much energy. What he really meant was that he wanted to have a bicycle with a good seat at the back apart from the rider. What the analyst understood was that well, it is a transport vehicle which two people can go comfortably, energy efficient and so on, and he kind of thought in his own mind of something like a cycle rickshaw, where one person rides and the other person sits at the back. And then when he designed, when he gave it to the ultimate designer, the designer kind of looked at this, and he said maybe it will be more stable if I put one more wheel, and made it a four-wheeler. So, what originally the person required a cycle, and he ended up getting a four-wheeler, which is extremely difficult to drive and so on. So, the point is that these kinds of cartoons and jokes abound in the literature in systems analysis and design, and the reason being that there is always misunderstanding when somebody says something and somebody understands something else. Okay. So, this misunderstanding is because of the non-clarity of natural language. The natural language, or the language you use for daily conversation, cannot by nature be all that precise. There will be always gray areas. Suppose the language is very precise, there won't be any need for lawyers at all in this world. Lawyers only kind of split hairs and try to find out some loopholes and stuff like that. So, the whole point is that one has to make sure that the understanding, mutual understanding is there, and that is made clear to the ultimate customer. I said the development of SRS is analyst examines the current system if there is any, and finds out any shortcomings, anything which is missing in the system, and checks with the user whether the what are the things which are missing and what is it that he wants to introduce in a new system. There may be a manual system already in place, and then there may not be satisfied with that system, and they might like to have something extra put into it, and that is what this analyst will try to find out and tell them this can be done. Ultimate aim of the analyst is to develop a systems requirement specification which is understandable by the user and which can be used for detailed design of the system. See, there are two parts to this. One part is that the SRS document is something which is agreed to between the customer or the user and the analyst, and the analyst gets this SRS more or less signed off. That is, the customer has to say that this is exactly what I require. So, unless the SRS is signed off by the customer, one should not proceed, because very often people do not produce a proper systems requirement document and get into deep trouble later on. I mean, I have been emphasizing it again and again, but it is very important, because it is important to be able to come up with a well defined systems requirement specification and saying what is required by the organization, and what is required, if it is made very clear. As I said, oral communication, written communication is always prone to misinterpretation. Misinterpretation can happen because understanding of the same sentence by two different people can be different. As I said, that is why there are lawyers in this world. Okay. So, it is always good to have something which is much more precise. Of course, at one end of the spectrum is the formal specification, which I said is not always possible. So, you have to have something which is not really formal, but still something which is precise enough. Getting back to my civil engineering or house construction example, the plan of the house is something which is understood by the house owner who is going to give the contract to the contractor. It is also understood by the contractor. Both sides understand it, because the language is that of a plan and the elevation and so on, and this is much more precise in terms of the plan will give you what is the length, what is the breadth, what is the height of the plan itself will give you length, breadth and the disposition of rooms and so on. The elevation will give you the height and the looks and stuff like that. And so, this specification language which has evolved over the years is actually a plan. Now, the plan on the one hand is understood by the user, on the other hand the architect draws up the plan can be given by the architect to the engineer who is going to build a building, and the engineer also understands it. Becomes a common language, and it becomes a link language between the user and ultimately the contractor, and the intermediary is the architect. Similarly, systems analyst is an intermediary working between a user and a designer on the other hand. So, the analyst is like an architect, and whatever he kind of gives as a specification goes to the designer who designed the system as per the specifications drawn up. So, if he misunderstands the specification, he will design a wrong system and ultimately it will not work. So, there is a absolutely there is a good need, or there is an essential need of having a tool which is understandable by both people. And very often we find that graphical tools are a lot more precise as opposed to writing out in terms of long sentences. There is the point I want to make is that specification written in plain English is not really is not as precise as specification which is more like a drawing, which is graphical, because graphical gives a better image in your own mind, human mind, in terms of understanding. So, we have to find out graphical tools which are appropriate for specifying. The tool must be such that the specification should be complete and unambiguous. In other words, what I mean by complete is that all requirements which the user felt should be fulfilled are fulfilled. Nothing should be left out. Completeness means nothing is forgotten or left out. As I said, very often what hurts system most is that the user thinks that it is understood or is told, but the analyst does not fully understand that certain things are unsaid by him, assumed to be known to everybody, is not so. So, completeness is an important part, one has to be careful, and again iterate with the customer that is this complete or is there something which I left out. And unambiguous means there should not be any inconsistencies in the specification. Inconsistency, there is some part of it, if you do, some part of it cannot be done, or they are contradictory. So, that kind of an ambiguity and contradictions can really ultimately, when the designer starts designing, he will find that he can't do much with it, because it is the specification is if he follows one part, some other part will not work. So, it is important to have an ambiguous specification. And as usual, specification must include operational, tactical and strategic requirements, all three, and very clearly. And once you have this all drawn up, it should eliminate possible later disputes between the users and the analysts. The ultimate idea of a good SRS is that later on in the life cycle of the system, there should not be any unresolved issues which will lead to disputes, and disputes can really become very uncomfortable for both the user and the analyst. So, dispute resolution is something which one should avoid. Very often, dispute is resolved by using arbitration and so on, but one should not really get into that stage if you are designing a good system. So, as I said, ideally one should use graphical aids, which is understood both by the user and by the who need not be computer literate, and also will be useful in design. A designer should understand it. It should be jargon free. What I mean by jargon free is you should not use computer terminology which is not understood by the general user. See, and there is no point in using certain kind of terminology which is not understood by the user. Normally, one starts with a narrative the requirements of users are given as a set of statements, sometimes written, sometimes oral, and mostly oral, which you get through interviews, and you take down notes, and as I said, at the end of interview and so on, you write down what you understood, and then you get it cleared by the user. So there is at the end of the interviewing process and fact gathering process, you have only what is known as a word statement, or a document written in plain English about what is required, and this has to be analyzed and quantified in some sense, that is, identify physical entities such as vendors, receiving office, inspection office, and so on. I will give an example to explain this, and documents, and then how the documents get from place to place to place within the organization. This will become clear with the example. I am just going to read out a certain word statement. There is a very simple word statement which can be said in a short period in a class. A much longer word statement for the same problem, which includes other steps in the process, is given in the textbook which I pointed out. In fact, in this textbook there is a long word statement in chapter 5 which essentially gives maybe what is at the end of an interview, and tries to kind of spend a little bit of time to extract from that statement more quantitative information which can ultimately lead to a graphical representation. The ultimate graphical representation we want to have are two. One is called a data flow diagram. The first one is called a document flow diagram. The second one is called a data flow diagram. We will now concentrate first on document flow diagram, and then we will get on to the data flow diagram, because document flow diagram is closer to what really goes on physically in the organization, whereas data flow diagram is something which is more appropriate for programming in a computer. The two are kind of, the data flow diagram is normally derived from the document flow diagram, but the purpose are somewhat different. The document flow diagram is something which is understood very clearly by the user, who may not understand the data flow diagram because it is more clearly understood by the designer. But then these two should correspond, and one can of course educate the customer on data flow diagram also once he understands the document flow diagram. Now, this statement says normally the manager will say our company receives many items from several vendors, each accompanied by a delivery note. Now, observe this sentence. He says our company receives many items from several vendors. It is completely imprecise. How many items? Is it 100 items, 1000 items, 10,000 items? Depending upon the number, you may have to kind of look at different methods of solving the problem. For a small number, that may be one good method. It's a very large number, that may be another method altogether. So, it's also important at that stage to be able to get some little bit quantification, saying normally how many items are received, and how many items are received in a day or in an hour, and what types of items come. Again he says several vendors, and how many vendors, are the same vendors supplying everything, or there are different vendors for different items and so on. Get some more detail, and each accompanied by a delivery note. Delivery note, what does the delivery note contain? That is important, because that is the basic data from which you are going to proceed and come up with a further analysis. So, a receiving office receives this item, the physical items flow, and checks the delivery note which comes along with the item with the corresponding order. There is an order for the item which has been placed with the vendor, and the vendor is supplying the item. When he supplies the item, it comes with the delivery note, and he should actually specify in the delivery note the order number against which the delivery is being given. So, in the design of the delivery note also, you have to make sure there is a linkage between the order and the delivery. If there is no linkage, you will not be able to essentially find out against what order it came, and you don't even know whether it has been sent by somebody by mistake. Okay. So, these are issues which we will look at as we proceed. And any discrepancy between what is in the order and what is actually in the delivery note is reported to the purchase office. Now, the question is, what is meant by discrepancy? Discrepancy could be that he has supplied more items, or he has supplied less items, or he has supplied the wrong item. So, there are number of possibilities, or it, you put a deadline saying that by this time should come, and he has delayed it by a long period, and you may not anymore require the item, and so on. So, these are discrepancies, and any discrepancy is reported to the purchase department, because purchase office is the one which originally initiated the order, and the items received along with the items received note with details of items is sent to an inspection office. In other words, items have come, you find no discrepancy on the face of it in terms of at least documents, because you are now comparing only documents, the document, delivery document with the order document, and there is a document comparison. It has nothing to do with the fact that the item may be of poor quality or may be wrong item. The note may say something, you may have ordered nuts, instead of that you may have supplied bolts. So, there is a need for an inspection office which inspects the physically the items which are delivered against the items which are ordered, based somewhat on the description also of the item. And this discrepancy again at the inspection office has got to be reported to the purchase office. So, these are essentially what is a word statement which is made by the user. So, once this statement is made, you have to identify the entities involved. What I mean by entities are the you might say nouns in the statement, or the actors who are involved in this entire process. In this case, the actors are the vendor who sends the items to you. The receiving office is an actor, in the sense that receiving office got somebody who receives the items and who will compare manually or maybe on the computer. Okay, if they are computerized, ultimately if you want to computerize it, then the delivery note should be in the computer, in a computerized form, and the order will always be already in your computer in the database, and you can compare the two. The receiving office is an entity, inspection office is another entity, and also purchase office is another entity. I have not specified that here, but there is a purchase office which is also an entity. All right. What else is there? Receiving office, the received note is a document. Okay, it is very different from the entity. Entity are the actors, you might say, who act on documents. So, in this case, the entities are vendor, receiver, inspector, and the purchaser. So, these are four entities involved in this simple type of a word statement or simple expression of what is done. observe again that this only says what is being done, and doesn't say anything about how it is being done, even to now or how they want to be done, get it done later on. The point that I made about computers and so on is based on how it will be may be done. Okay. So, it is not at this time anything about how it is done. And you also identify documents. Documents are in this case delivery note, because it comes with the items, a discrepancy note, that is when you compare the delivery note along with the order. In fact, you can see here there is order received, items received note is there, is quite different, and delivery note is there. In fact, one of the documents which is identified, which is not stated very clearly here. In fact, I think it is an oversight. Intentionally I did it, because I thought you should actually look at it. And if it is a class, you would put your hand up and say, sir, you have made a mistake, because there is a document which is the order, because unless the order is there, I can't compare it with the delivery note. So, order is missing. So, order is also a document which has got to be identified. So, order, purchase order, delivery note and items received note, because items received note could be different from the delivery note, because at the inspection you may find that he has said he has delivered 100 items, but actually only 90 have come. And discrepancy. The discrepancy is in terms of different item, what you did not require, it comes. So, going back, so given the narratives, you analyze the statement, identify physical entities such as vendors, receiving office and so on, inspection office, and identify documents which are received and sent by each office, and the physical get a physical document. So, based on this, you come up with something called a physical document flow diagram, and a physical document flow diagram will consist of the parts which are all the entities, the flow of documents, and this disposition of documents. So, it is a graph connecting entities with other entities and through documents which flows between these entities. So, I will revert back to this of how to draw a detailed document flow diagram next time with certain amount, because we have to discuss it in greater detail. I do not want to hurry through that, because I am already getting to the end of this lecture. So, you think a little bit about it, and so see how you can kind of draw a document flow diagram using entities and documents.